Hi guys, let's talk a bit about vectors now. Vectors consist of basically two numbers. We write a vector as a letter with a little line on top. And we create a column. We have two brackets and two numbers. The first number on top will be called the x and the one on the bottom will be y. For example, let's define a vector a which has the top number to be 2 and the bottom number to be 1. So in other words, x is 2 and y is 1. We can graphically show a vector as a line. In this case, x is 2, so we start at the origin and we move 2 to the right. And y is 1, so we move 1 up. We can show a vector as a line like this. And this coordinate point is 2, 1. Let's do another example. Let's say the vector b is equal to 5 and 3. So we count 5 to the right and 3 up. How about vector c? Vector c is 1, 5. Can you figure out what this vector c looks like graphically? That's right, we move 1 to the right and 5 up. What about vector d? D is -2 and -3. This one is a bit more tricky. Let's see, what does this vector look like? It goes in the negative x direction by 2 and it goes in the negative y direction by 3. What about the vector e? Let's say vector e is 6, -2. That means we move in the positive x direction 6 and in the negative y direction we move 2. As you can imagine, vectors can be very useful for engineers and scientists. This is because they have both a direction and a size. We can use them to express anything that has both a direction and a size. For example, we can use them to express forces, wind direction, or even give a route description on a map. Here I use the vectors a, b, c, d, and e to give an interesting route description. Can you figure out from this diagram which vector has what value? So a moves 2 in the positive x direction and 1 in the positive y direction, so we can write a as 2, 1. B moves 0 in the positive x direction and 2 in the positive y direction, so we write it as 0, 2. C moves again 2 in the x direction and 1 in the y direction. D moves 2 in the x direction and 1 in the negative y direction. And E moves 1 in the negative x direction and 2 in the negative y direction. If we add up all these vectors, we can get there in a single step. That will result in a vector which looks like this. Let's call it the z vector. The z vector is equal to the a vector plus the b vector plus the c vector plus the d vector plus the e vector. If you want to work this out, you just have to add all the x values, and that will be the new x value, and add all the y values, and that will be the new y value. Why not try it yourself? As I mentioned, one good thing about vectors is that they have a size and a direction. So we can express the vector in terms of its length and its direction. Let's call the angle theta and let's call the length L. We can easily convert between this length and this angle and the coordinate system. So in other words, if we know the x and the y value of the vector, we can calculate the length and the angle. And if we know the length and the angle, we can calculate the x and the y component of the vector. So the y component is a vertical component and the x component is a horizontal component. let's call the value of the y component y, and let's call the value of the x component x. So how can we relate the length and the angle to the x and the y components? We use trigonometry. X is the length times the cosine of theta, and y is equal to the length times the sine of theta. So this is how we can convert a length and an angle into an x component and a y component. Usually in maths we have the x-axis facing from the left to the right and the y-axis facing from bottom to up. That means that the positive x direction is facing towards the right and the positive y direction is facing upwards. For some reason in computer screens it's not quite the same. In computer screens you have the 0, 0 on the top left corner. You have the y-axis facing downwards and the x-axis facing towards the right. So the top left corner is the 0, 0 mark. Top right corner has a y coordinate of 0 and the x coordinate of the screen width. Bottom left corner has a 0x and the window height as a y coordinate. While the bottom right of the window has got a y coordinate of the height and an x coordinate equal to the width of the window. That means that whenever the y component of a vector is positive, it's actually facing downwards, not upwards as we've been learning before. In this case we've got the vector a, and the x component is 2 and the y component is also 2. But what if we had the vector b and it had an x component of -2 and a y component of 2? And what if we had the vector c with an x component of -3 and a y component of -1? A vector d has got the x component of 2 and a y component of -2. Let's see what these vectors would look like in the Godot coordinate reference frame. Starting with vector b, it goes -2 to the right and 2 positive, so 2 downwards. Vector c is going -3, that means it goes to the left, and it goes 1 upwards because it's -1. Vector d goes 2 to the right because the x component is positive, and it goes 2 upwards because the y component is negative. So I hope that if you didn't know anything about vectors before, that this video helps you out a bit. In principle it's quite simple. You just have to bear in mind that each vector has an x component and a y component, and the x component and the y component together result in a direction or an angle and a magnitude or a size. So hopefully this was helpful. Thanks for watching. See you later.